So welcome to video lecture on microprocessor. In the previous lecture, in lecture 1, we have discussed about decimal number system, binary number system, hexadecimal number system, conversion among these number systems. In lecture 2, we have covered signed number, unsigned number, the conversion from unsigned, signed binary decimal number, and the range of unsigned and signed number. Before starting lecture 3, say go through lecture 1 as well as lecture 2. In this lecture, I am going to discuss about programmer's model of 8086 microprocessor. This is the topic what I am going to discuss. Now tell me, which hardware unit required to store binary information? Because we have discussed the number system, how to store negative number, how to store unsigned number, a signed number, and we know that the computer stores each and every information in terms of binary. Either it may be a text, or it may be image, or it may be audio, or it may be a video. Whatever it may be the form, finally the computer stores every information in terms of zeros and ones. Tell me, Kaushik, which hardware we require to store a binary information? Just I'm talking about a single bit. Kavana, any answer for this? Because I need some hardware. We have discussed about a number system. Okay, the conversion from one number system to another number system. So we know. Okay, now my question is which hardware we require? Which hardware we require to store the bit 0 or 1? Any answer for this? The answer is the flip-flop. The flip-flop is a hardware. So what is flip-flop? Flip-flop is a 1-bit storage device which is used to store either 0 or 1. It is a flip-flop. Using flip-flop we can store 0 or 1. It is a 1-bit storage device. It is a hardware. Therefore, if you want to store 1 bit of information, okay, the computer uses the flip-flop. Okay, what is flip-flop here? Flip-flop is a 1-bit storage device which is used to store either 0 or 1. Now tell me then how to store more than 1 bit? Kaushik, tell me, which hardware unit required to store more than 1 bit? So we know that if you want to store 1 bit, we have to go for a flip-flop. Then how to store more than 1 bit? Suppose I want to store 8-bit information, or I want to store 16-bit data, or I want to store 32-bit data, or it may be a 64-bit data. Therefore, which hardware unit we require to store more than 1 bit? The answer is the register. So what is register? Register is nothing but a group of flip-flop. What is register? Register is a group of flip-flop which is used to store more than 1 bit. If you want to store just 1 bit, you can use flip-flop. But if you want to store more than 1 bit, we can go for a register. The group of flip-flop forms a register. Say example like this. So here, see, this is, we can say flip-flop 0, flip-flop 1, flip-flop 2, flip-flop 3, like that, flip-flop 7. So how many flip-flops we have here? Totally 8 flip-flop. This 8 flip-flop forms a register. Then what is the size of this register? 8-bit register. So B0, B7, B0 to B7. Therefore, it's a register. Depending upon your convenient, you can use some name for this. But if you go for a microprocessor, they're going to give some name for this. Suppose here AL register, BL register, CL register. It's something like that. Therefore, in general, what is register? Register is a group of flip-flop which is used to store more than 1 bit. Here, if you want to store 16-bit, just we can extend B0 to B15. Then if you want to store 32-bit, then you have to go for a 32-bit register, that is from B0 to B31. It's something like this. Then here just I'm going to talk about 8086 microprocessor. So tell me how many registers are available in 8086 microprocessor. Kaushik. So tell me how many registers are available in 8086 microprocessor. I think all of you are aware of the internal architecture of 8086 microprocessor. Now tell me how many registers are available in total inside the 8086 or 8088 microprocessor. So actually we have 14 registers. So microprocessor is nothing but a semiconductor device which is fabricated on VLSI technology. So here inside, just if we enter into the microprocessor, so how many registers are there? What is the purpose of using registers? To store the information. Either it may be data, or it may be address, or it may be final result, or if you want to do any manipulation, we have to go for a register. Actually the register behaves like a memory unit. It's just like a memory to store any information temporarily. It's not possible to store information permanently. Only at the time of execution, at runtime, we can able to use these registers. Later it is not possible to get back those informations. Means what is the purpose of using register? To store the informations temporarily at runtime. Means if you want to perform any manipulations, addition, subtraction, division, multiplication, whatever it may be, if you want to do any arithmetic and logical operations, we require registers. Without registers, it is not possible to perform any operation in assembly language program. Suppose if you go for a higher level language like C, C++, without knowing any details of microprocessor, we can start writing the program, but here not possible. Therefore, even if you want to write very simple program, even if you want to add 2 8-bit number, add 2 16-bit number, whatever it may be, at least we have to know something about the programmer's model. Then only you can proceed, we can start writing the program, otherwise not possible. Therefore, here if you go for 8086 microprocessor, inside the microprocessor we have totally 14 registers. Which are those? Here we have we can classify into so many groups: 4 data registers, 2 index register, 2 pointer register, 4 segment register, instruction pointer, and there will be a flag register. So here 4 plus 2 6 8, that is for 12, and 2 here 14. So totally we have 40 registers. That's all. But if you go for a microcontroller, we have hundreds of registers. But if you go for a microprocessor, we have limited number of registers. What is the purpose of using registers, Kavana? Tell me, what is the purpose of using registers? To store the information temporarily. It is not possible to store the information permanently. Only at runtime we can able to use. Afterwards it is not possible to use those registers. Okay, it's also called programmers registers, programmers visible registers. It's something like that. Okay, therefore using registers we can able to perform the operations. If you want to do any operations, we require registers. Without registers it is not possible to write any program in assembly language. Even if you want to add 2 numbers, or if you want to do any simple operation, we require registers. Using registers we can store temporary information. In 8086 we have totally 14 registers. Means these registers are available to the programmer. At the time of writing program, he can use those registers in the instructions. Okay. Now this is the programmer's model of 8086 or 8088 microprocessor. We have some difference. So later we can able to discuss the difference between 8086 and 8088. So in this video lecture, just I am concentrating on programs, how to write program in assembly language using 8086 microprocessor. That is my main concentration. Now here we know that we have 4 data registers: AX, BX, CX, DX. A for accumulator, base register, count register, data registers. That is, we have 4 registers, data registers. Then source index, destination index, stack pointer, base pointer, 2 index register, 2 pointer register, and 4 segment registers: code segment, data segment, stack segment, extra segment. Then IP stands for instruction pointer, FR stands for flag register. What is the size of all these registers? That is 16-bit. From 0 to 15, 16-bit. All are 16-bit in size. Means we can able to store 16-bit of information. Okay. Here sometime I'm going to ask you to perform 8-bit manipulation, 8-bit addition, 8-bit subtraction, 8-bit multiplication, 8-bit division. How to implement? How to achieve this? Then we require some 8-bit register. Now here in 8086 we have 8 8-bit register. We have 8 8-bit register. Means here AX, X stands for 16-bit. A stands for accumulator. AX means it's 16-bit register. We are dividing this AX into 2 parts. That is from 0 to 7 we can call it as AL, accumulator lower. Then from 8 to 15 we can call it as AH, accumulator higher order. Okay, in the same way the BX is divided into 2 parts, that is BL lower order and BH higher order. B stands for base. In the same manner the count register, the CX count register is divided into 2 parts, CL, that is from 0 to 7 8-bit register, and CH is also another 8-bit register. What about this DX? Now we can divide DX into once again 2 parts, DL 8-bit and DH 8-bit. Therefore say here we have 8 8-bit registers, AL, BL, CL, DL, that is 4 lower order 8-bit, AH, BH, CH, DH, here 4 higher order registers. Totally we have 8-bit, but it's not possible to divide SI, DI, SP, BP. It's not possible to use all this register as a 8-bit register. We have to use all this register as a 16-bit register. It is not possible to use this as 8-bit register. Therefore, if you want to perform any 8-bit manipulation, any 8-bit arithmetic or logical operations or data transfer operations, then we have to go for these 8 registers. That is AL, BL, CL, DL or AH, BH, CH, DH. Okay. Therefore, if you want to perform any 8-bit manipulation, we have to go for this. And whenever writing some program, we are not supposed to mix this 8-bit with 16-bit or 16-bit with 8-bit. Okay. Any doubts here? Now I am not able to cover each and everything in this lecture. Just I'm keep explaining some important things. So next is just same thing. How many 8-bit registers are available in 8086 microprocessor? That is what is the answer? Tell me, Kavana. That is 8 registers. We know. Which are those registers? AL, BL, that's AH, BL, BH, CL, CH, DL and DH. All are 8-bit registers. What is the size? 8-bit. 8-bit in size. 8-bit in size. Therefore, using these registers, we can able to store 8-bit signed number, 8-bit unsigned number, or we can store some other information. Therefore, if we want to perform any arithmetic and logical operations, we have to use registers, these 8-bit registers. Okay, suppose I'm going to ask you to add to 8-bit number, then I have to use any one of these. Oh, okay. Or I'm going to ask you to perform some logical operation, AND operation, OR operation, exclusive OR operation, or NOT operation, then we have to use this. Okay. Now tell me, what is the minimum and maximum unsigned number can store in 8-bit register? You know what is the size of this? You know, we have discussed in the previous slide. That is, we have 8 8-bit register. My question is, what is the minimum we can store, minimum number we can store, and what is the maximum number we can store? See here. That is, here I am expressing in 3 a different number system. This is, we know, it's hexadecimal number system. It is in binary, it is in decimal. Therefore, if you put all zeros here, how many zeros? 8 zeros. That gives first number, that is minimum. If you put all ones, that gives the last number, that is maximum, that is 255. 255 in decimal, FF in hexadecimal, and this is in what? Binary. Therefore 0, 1, 2, like 254. The last number is 254, the 255. Therefore the minimum is 0, the maximum is 255. Therefore in using 8-bit register, it is not possible to store more than 255. Maximum 255. 256 not possible. 250 is not possible. Okay, we can able to accommodate maximum 255. Then if you want to store more than 255, then you have to increase the size of the register. Means you have to go for 16-bit. Next level is 16-bit. It is not possible to use 9-bit. There is no 9-bit register. There is no 10-bit registers. Okay, after 8-bit, next is 16-bit. After 16-bit, we can go for 32-bit. That is 386 microprocessor and all. Any doubts, Kaushik? Kavana? Any doubts here? No doubt? Shall I proceed further? Okay, now here, what is the minimum and maximum signed number can store in 8-bit register? Just in the previous case, we are talking about 8-bit registers. How many 8-bit registers we have in an 8086 microprocessor? AL, AH, BL, BH, CL, CH, DL, DH. Okay, then what is the minimum and maximum unsigned? I'm talking about unsigned number can store in 8-bit register. We know that always unsigned numbers start from 0. Okay, 0, because here there is no, it's not, there is no like positive or negative. Unsigned means only magnitude, there is no sign at all. Therefore the minimum is 0, the maximum is 255. It is not possible to store more than 255 using 8-bit registers. Okay, what is the minimum and maximum signed number can store in 8-bit register? 8-bit register, I'm talking about which number? Signed number using 8-bit register. See here, I am expressing once again a 3 number system. This is in hexa, it is in binary, and this is decimal. Okay, if all zeros here, that is first 0. Actually here MSP is reserved for sign. 0 means positive, 1 means negative. Therefore here from here to here all zeros, that is positive number. That is from 00 to 7F in hexa, or 0 to plus 127. Here minimum is 0, positive number. What is the maximum positive number we can store? Plus 127. In the same manner, what is the minimum negative number we can store using 8-bit register? That is minimum we can store minus 128. This is minus 128. What is the maximum number we can store? What is the maximum number we can store? I think here there will be some wrong is there. The binary equivalent of 80 is not this. Actually, what is the binary equivalent of 80? Here 1, 0, 0, 0, 0, 0, 0, 0. That is minus 128. Okay. So this is 7F. After 7F, 80. 80 in hexa equal to, what is the binary equivalent of 80? It's something a mistake here. Here 1 followed by 0, 0, 0, 0, 0, 0, 0. Here the 1 followed by 7 zeros. That becomes 1 minus 128, and here 18 hexadecimal. That is minimum number. What is maximum number? Maximum negative number. We know that minus 1 is greater than minus 128. Here minimum is minus 128. The maximum negative number is what? Minus 1. This is minus 1. In hexadecimal, FF. In decimal, minus 1. And in binary, this I explained in the previous lecture. So how to represent minus 1. That you have to go for 2's complement method. Therefore, what is the minimum and maximum signed number can store in 8-bit register? That is minimum positive number is 0. The maximum positive number is plus 127. Minimum negative number is minus 128. The maximum is minus 1. Okay. Then, which instruction is used to store 8-bit signed or unsigned number in 8086 microprocessor? Now just we have discussed about hardware. What is register? It's hardware. Okay. How many registers we have in 8086? We have 14 registers. How many 8-bit registers we have? We have 8 registers. Okay. And each and every register has its own name. You are not supposed to use your own name. AL, BL, it's predefined. Whenever writing the program, we have to use only those register name, AX, BX, CX, DX, SI, DI. It is predefined. You are not supposed to use your own name. You are not supposed to give your own name. You are not supposed to define your own name. Therefore, here that is hardware. Then how to control that hardware? How to control that particular hardware? Now here the question is, which instruction is used to store 8-bit signed or unsigned number in 8086 microprocessor? 8086 microprocessor. 8086 microprocessor. 8086 microprocessor. Therefore, in this case, here let it be which instruction is used to store 8-bit signed and unsigned number in 8086 microprocessor. The answer is, say here it's a general format. It's a general format. Using this format, we can write so many versions. Okay, move R8, 8-bit number. Either it may be signed or unsigned number. In Hexa, we can write in hexadecimal form, or you can write in decimal form, or we can write in binary form also. Okay, this is the general format, that is R8 in general. What is 8? 8-bit. R stand for register, 8-bit register. So how many registers we have in 8086? We have 8, AL, AH, BL, BH, CL, CH, DL, DH. We can replace this R8 by any one of this, and it's a data. Therefore, if you want to store any immediate number, immediate data to register, we can go for this. Okay, then write instruction to perform the following operations. Load 23 to AL, 255 to BH register, -1 to CL, something like this. Okay, next consider one by one. Load 23 to AL register. What is the size of this number 23? 8-bit. Load this 23 into AL. Okay, which instruction we require? Which instruction? Tell me, which instruction? Just we have discussed general format in the previous slide. Therefore, we know that the general format is move R8, 8-bit number. 8-bit number. It must be 8-bit number. Okay. Now here move AL, 23H. Move AL, 23H. So if we try to execute this instruction, the 23 goes to AL. We have some information AL. It's going to overwrite. AL becomes 23. Hexa, because if you write 23H, it will store as it is. It won't convert. So what is the binary equivalent of 2? 0, 0, 1, 0 and 3, 0, 0, 1, 1. That is 8-bit. 2 requires 4-bit. 3 requires 4-bit. That totally put together 8-bit. That goes to AL. 8 4-bit, 3 8-bit, put together 8-bit. That goes to where? AL. Always AL will store in terms of binary. But if we try to check the result, sometime we are going to see each and every information in terms of hexadecimal. Okay. Next, load 255 to BH register. 255 to BH register. What is 255? It is decimal number. Okay, you can write decimal number also. So load 255 to BH register. So tell me, Kaushik, what's the answer for this? Now here move BH, 255. Now if you write this, it will convert 255 into equivalent binary, then to store into BH register. What's the binary equivalent of 255? 8 ones. 1, 1, 1, 1. Say 8 ones. That 8 ones goes to BH. 8 ones goes to BH. What's the hexadecimal equivalent of 255? FF. Therefore, if you try to see the output in BH, we'll get either in the form of binary or in the form of hexadecimal. Therefore, if you try to write any number, it will convert into binary. Okay. So most of the software, simulation software, there it is going to display the answer in terms of hexadecimal. Even if we write move BH, 255, it is not possible to see 255 as it is. We can able to see FF. What's the content of BH? FF in hexadecimal. Okay. Load -1 to CL register. What's the instruction? Move CL, -1. -1 in, it's a negative number. Then it won't store -1 as it is in CL register. Then tell me what is the content of CL? Now CL contains FF. CL contains what? FF. Now here it would treat 255 something like unsigned number. It will store FF. But here move CL, -1. It's a signed number. What is the binary equivalent of -1? We have discussed in the previous lecture and slides. Okay, what is the binary equivalent of -1? That is 8 ones. 8 ones, it is a negative number. That is, what is the content of CL after executing this instruction? FF. You can see FF. It is not possible to see -1 as it is. If we try to execute this instruction, we can able to see what? FF, not -1. Next, load 2FH to DL register. Load 2FH to where? To DL register. What is the instruction? Move DL comma 2FH. So if you, one more very important point is, if you want to store any data, okay, the data must start with digit, not by character. Okay, whatever it may be data, either it may be 8-bit number or it may be 16-bit number, the number must start with digit, anything from 0 to 9. 0 to 9. You are not supposed to start with what? Character, means X digit. We know X characters are there from A through F. Just one more example. See here, load B9H to H register. Here B is a character. B is not a digit, it's a character. That is, we know A, B, C, D, like that. Therefore, it's a valid number, even though if we try to write like directly move H comma B9H, there will be error. Therefore, we have to prefix with 0. It means it's going to convey the message to the assembler. Say B9 is a number, hexadecimal number. It will store B9 as it is in H register. Okay. So load 10100110 B stands for binary to DH register. So move DH comma binary data. So what's the content of DH? 1010A 01106. Therefore the content of DH is A6. 1010A and this is 6. Content of DH is A6. Okay. Then how many data registers are available in 8086 microprocessor? We have AX, BX, CX, DX. So we have how many registers? We have 4 registers. Using these 4 registers, we can able to manipulate 16-bit operation. We can able to manipulate what? 16-bit operation. We can perform 16-bit arithmetic and logical operations. Suppose I'm going to ask you to perform 16-bit addition, multiplication, division, like that. Most of the time we have to go for this registers AX, BX, CX, DX to perform arithmetic and logical 16-bit operations. Here from 0 to 15, so 16-bit, and using, we can divide this into 2 parts. We can able to use this also 8-bit registers AL, H, BL, BH, CL, CH, DL, DH. Therefore, with the help of this, we can able to perform 8-bit and 16-bit arithmetic and logical operations. Okay, what is the minimum and maximum unsigned number can store in 16-bit register? What is minimum? All zeros, that gives first number. Minimum all ones. Sorry, here also I made a mistake. This actually all ones. This is not a zeros. So just I copy and paste. That's why there's a mistake here. That is here all ones. Here what is this? All ones. Okay, all ones. That is nothing but what? 65,535. That is maximum. This is in hexa. That is actually F. What is the meaning hexadecimal equivalent of F? 1111. Okay, here 111. Therefore, here all ones gives the last number. All zeros gives what? The first number, means actually minimum number. Minimum, and the last combination gives maximum. Okay. Now here I think I corrected that error here. Here, what is the minimum maximum sign number can store in 16-bit register? See, all zeros. Okay, is a positive number. Here see MSP. Reserved for sign, 0 for positive and 1 for negative. Here we have so many combinations. Just like mentioned the first and last combination. Here, what is first minimum positive number? 0. What is the maximum positive number? 32,767 maximum. What is the minimum negative number? Minimum negative number 1 followed by all zeros. That is 8,000H. That is nothing but minus 32,768. That is minimum. Then all ones, that is minus 1, that is maximum. Okay, that is all ones. It's nothing but minus 1. I'm talking about sign number. All ones, if you treat, suppose assume it's unsigned number, by the time 65,535. If we treat same thing as unsigned number, what's the magnitude? 65,535. If we treat this as signed number, then what's the value of this? That is -1. That is -1. Getting this idea? Therefore, if you go for unsigned, the first number is 0, the last number is 65,535 if it is unsigned. But if it is signed, we can have 32,768 positive number and 32,768 negative number. Then how many numbers we can have totally? 65,536 numbers we can store using 16-bit register. Therefore, here there will be a positive minimum and maximum, and there will be a negative minimum and maximum. Okay, which instructions used to store 16-bit signed or unsigned number in 8086 microprocessor? What is the answer? That is move R16, 16-bit signed and unsigned. What is R16? The means it may be AX, BX, CX, DX, and we have source index, it's also 16-bit register, DI destination index 16-bit register, stack pointer and base pointer, all are 16-bit register. We can load 16-bit number directly into this register. Suppose I am going to ask you to store some 20,000 into this AX register. We can write move AX, 20,000 like this. Okay. Write instruction to perform the following operations. Okay, load 1, 2, 3, 4 H to AX register. Say move AX, 1, 2, 3, 4 H. Like load 65,535 to BX register. I can write directly move BX, 65,535. But at the time of execution, okay, it's going to store everything in the form of what? Hexadecimal. Inside machine level is binary, but at the time of execution, suppose if you want to see the output, the BX gives the answer in terms of hexadecimal, not in terms of decimal. What is the hexadecimal equivalent of this? F, 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 F. That is 4F. What is the content of BX? FF, FF. Okay, that's a value. Now here load -1 to CX register. See, it is unsigned number. Okay, it will treat something like that. Now here if it is negative, it is going to store in 2's complement form. Okay, 2's complement form. If the number is negative, okay, it's going to store in which form? 2's complement form. Therefore, just I can write directly move CX, -1. But what is the content of CX? Tell me what is the content of CX. Now CX contains F, 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 F. Okay, what is the binary equivalent of -1? 16 ones. What is the size of CX? 16-bit. Then what is the content of CX in the form of binary? 16 ones. What is the hexadecimal equivalent of that? FF, FF. What is the, if you treat that FF, FF as signed number, what is the decimal equivalent of this? -1. Okay, -1. Later I am going to give demo for all these things. Okay. Load ABF9H to DX register. Here you can observe one thing, it's a 16-bit number. So there is no doubt, it's a valid number, fine. But if you want to write instruction, okay, always the data start with digit. But we know that ABF9 is a valid hexadecimal number. Okay, you are not supposed to write move DX, ABF9H. What we have to do for this? We have to prefix with 0. Then it convey the message, tells the assembler it is a number. It's a number. Otherwise, if you write ABF9H directly, it will treat this as some memory location, name of the location. It will treat this as a symbol. It's a variable. It's an identifier. It is not defined anywhere. Okay, then there will be error. It is going to display error message. Okay, therefore move DX, 0. I'm going to prefix 0 here. 0 ABF9H. Okay, suppose if you write directly move DX, ABF9H, so there will be error. Okay, how to remove that error? You have to prefix with 0 because data has to start with digit. Therefore, we know that ABF9, I want to store ABF9 as it is. Therefore, say if you try to write directly this number, there will be error. Therefore, how to remove that error? 0. If you write 0 here, then it's going to convey the message to the assembler. Okay, it is a hexadecimal number. Okay, for more details you can visit website srinivashetty.com. So thank you.